Hello and welcome, everybody. We're so glad to have you here today, tuning in from all over the world. We have one thing in common today, at least, which is that we're interested in building and operating a certificate authority on AWS. So I'm just going to jump right into it so we could get hands-on as quickly as possible. But I wanted to introduce the team. My name's Anthony. We have Zach and Ram, who are co-creators of this workshop, and we'll be helping moderate and answer your questions. So let's jump right in. So the agenda of today, we have about an hour and a half together, and we encourage you to ask questions throughout. We'll start off with a short presentation. This will be about 5 to 10 minutes to cover the major topics of the workshop. And then we're going to get hands-on, and you'll be able to build and to operate and to learn through the workshop yourselves. At the end of the final maybe 10 minutes, we'll have time for live challenges where you'll complete a quiz. It's a gamified quiz that'll sort of reinforce the learning throughout. So let's talk about what tools we're using within this workshop. So we're going to use Python and the Python Boto 3 library throughout the workshop. And the key AWS services that we'll be utilizing are obviously ACM Private Certificate Authority, AWS Cloud9, Security Hub, Amazon EKS, and IoT Core. So before we jump into what the workshop will cover, let's talk about what ACM Private CA is and the benefits that it offers for those not familiar. So ACM Private CA is a managed private certificate authority service without the upfront investment and ongoing maintenance costs of operating your own private CA. This means that you no longer have to build and own your CA infrastructure. It's extremely secure. It's backed by a FIPS 140-2 Level 3 HSM for operating the CA's private keys, and that's fully managed, so you don't have to manage the HSMs. It gives you access to fine-grained controls and auditing as well as logging out of the box. And it helps you automate certificate creation either through automation or through API like access for like your applications to use the API. And finally, it's a pay-as-you-go pricing. So like we said, there's no upfront fees. You pay for exactly what you use. And the more certificates that you issue, the less the per certificate cost actually is. Now, one thing I like to highlight is that this is for private websites. If we think about beyond public-facing internet applications, there's a whole slew of private applications that are either deployed on AWS or on-prem or a combination that need to be secured. And so these are internal applications within an enterprise or within an organization. Now, the components of the private CA are similar to a public CA. However, the public CA must issue and validate certificates for resources on the public internet, whereas the private CA does the same, but for private networks. One key difference is that applications and browsers trust public certificates automatically within the browser, whereas an administrator within your organization must explicitly configure applications to trust certificates that are issued by private CAs. And so this workshop will cover the private CA workloads. Now, what are those workloads? So there's a bunch of workloads that you can use with ACM Private CA. First and foremost, you can implement end-to-end encryption to either AWS resources, on-prem resources, or a combination of the two. You can implement IoT devices and applications. So you can issue certificates for your IoT devices or for your manufactured devices. You can provide real-time certificates for service meshes or container workloads like EKS or ECS. And finally, you can issue identity certificates for devices, machines, and users. Okay, so that's a background on what ACM Private CA is, but let's talk about what this workshop will cover. So there's a few modules. Now, We're not going to have time to hit on each and every module within the next 1.5 hours, but we're going to hit on at least one or two. And this workshop is publicly available. And so you can go and actually complete the rest of the modules on your own. And you can complete specific modules that you and your organization are actually interested in. But the one we'll be completing together, and the first module, is using private certificates with application load balancers. This is the architecture of the first module. As you can see, we use a serverless web application that uses Lambda, Route 53, and the application load balancer to host an internal website for an organization. We then show you how you can secure this private application with a TLS certificate that's generated through ACM Private CA and actually loaded on the application load balancer. So that's the first one we'll do together. We'll also be setting up a CA hierarchy together, even before we jump into this module. The other module is security monitoring. So now that you've set up your private certificate authority hierarchy, we want to be able to accurately audit and monitor what we call privileged actions. So this includes root CA, rotation, certificate rotation, and other highly authorized applications. We have tools that enable you to do this, and this includes sending events through CloudWatch to Lambda, which then populates it within Security Hub. Now, Security Hub allows you to have that single pane of glass and view your security findings. And so this integrates with Private CA, and a module walks you through that. Another module that you can optionally take afterwards is the flexible templates. So certificate types are mostly defined by key usage and extended key usage parameters. Some of you might need to create specific types of certificates like email certificates or CA certificates or custom and entity TLS certificates. There are many certificate types that you may need within your organization. Therefore, we've made it easy to provision these types of certificates using what we call certificate templates. You can think of these as a baseline that you can build on top of and customize for your specific use case. So this module walks you through how to do that in great detail. We also have a module on IoT workloads. So if you have a manufacturing use case or an IoT use case, we'll walk you through how to integrate ACM Private CA with your IoT workload. Now, keep in mind, this doesn't just have to be IoT core. This can be IoT devices that you have that are outside of AWS as well. And finally, we have a containers module. So if you're running containers, whether it's EKS or ECS, you can, or like on-prem containers, you can use ACM Private CA to secure TLS communication between pods and between services. And so this workshop module will walk you through how to create the ingress controller and how to enable pod-to-pod encryption with ACM Private CA. Great. Okay, so I promised a short presentation. That's all I have for background. I really want us to jump in together. So one disclaimer though, the workshop creates a CA hierarchy that's shown on the right side of the screen right now. So we have a root CA, a subordinate CA, and that subordinate CA does the issuing of these certificates. Now, typically within a production workload, you might want to split out the intermediate CA or the subordinate CA, as well as an issuing CA, have a dedicated certificate authority that just does the issuing of the certificates. We simplified this for educational purposes, but wanted to highlight that you may want to think about splitting that out in actual production workloads. With that, I want everyone to jump into the workshop. And so what we're going to do here is if you can navigate to the link, we'll provide it within the chat as well, so you can just click on it, or you can use this URL. And we'll also provide you an event hash code that will give you a temporary AWS account that you should use for this workshop. this is very important that you sign out of any AWS account that you're currently signed into right now first, whether that's personal or through your organization. Please sign out, and we'll actually provide you a temporary workshop account that comes pre-configured. So I'm going to pause here and let everyone transition to the workshop. From there, I will walk everyone through the workshop together. And keep in mind that it's okay if you fall behind or you speed up, but I just want to create a baseline so we're all walking through it somewhat together. And for those that fall behind, that's okay too. We're going to try to go as slow as possible. But keep in mind, this workshop is publicly available, and you can come back to any module you want at any time you want. Okay. So I am going to transition as well to the workshop. And if there are any questions on the presentation, we'll pause here as well for any questions you could put in the chat. All right, so we're just going to pause and make sure everyone has all the information they need. So this is very important. Once you get to the workshop link, you may not be on this exact page. What I want you to do is to go on the left-hand navigation and click within Start the Workshop. There's a drop-down that says at an AWS event. And so this is an AWS event. It's a virtual one. And you'll want to click on that as your starting point. So make sure you see this. If you are participating within this virtual workshop live. If you come back and want to do it later, you can follow the instructions for an on your own walkthrough. But for now, we're going to use at an AWS event. So that's very important. Okay, great. I don't see any questions coming in, so I'll assume that everyone is doing all right so far. So now we're going to actually log into your temporary AWS account for this workshop. Now, all the instructions are listed here within the at an AWS event page. And so what you'll want to do is you'll want to open this link, this dashboard.eventengine.run link. You can do it in a new tab. And you should see this page. So I'm going to go very slow for this part because this is the most important part on how to actually log in. And it's a little tricky. So if you see this, you're in good shape. Now what you're going to do is you're going to copy in that event hash that we've listed in the chat. It should start with 6208, and it should end with AC. So you can copy and paste that within this box here and hit accept terms and login. And then you should see this. So this is the dashboard. You're going to ignore everything except for this button right here that says AWS console. You want an AWS console that you can use, and you want to log into your AWS account. So you'll click on AWS console right here, and that'll pop up a window. Now, for this virtual workshop today, we are using US East 2. So make sure to stay within that region. The instructions may say otherwise, but for today, if you're doing this live with us, please stay within US East 2. And then you'll go ahead and you'll hit the Open Console button. And that will open a new page with your workshop temporary AWS account. And if you want, you can switch to the new console. Great. So you should see this. Now, it's really important if you're doing this with us live to make sure that you're not using your personal or your work AWS account, that you're using this process that we just went through. To verify this, you'll look on the top right, and you should see that the role starts with team role. If you see that, you're good to go. You should also confirm that you're in Ohio, the Ohio region. If you see that, you're good to go. I'll just pause real quick to make sure there are no questions on that, and I'll give you guys some time to get here. Okay, great. So what I recommend is having two tabs, one tab with the AWS console that you're using that we've just logged into, and one tab with the workshop instructions, because we're going to be going back and forth. So you can scroll all the way down. We did all this together, so you don't have to read through this if you don't want. If you fell behind somewhere here, you can read through it, but this is just explaining how to log in. Now, you may have a situation where it asks you to sign in. And if this happens, you'll just want to either log in with your email or with your Amazon account, your retail account. I would recommend the one-time password. It will send a one-time password to your email, and then you'll type in that one-time password to actually log into this temporary AWS account. That may pop up. So once you're logged into this temporary account, and you have two tabs, one with the console and one with the instructions, you're going to go to the next step, which is called the CA hierarchy setup. And here we are here. So now that we've logged in, we want to actually create a CA hierarchy. And we want to show you how easy it is and how quickly you can actually create a CA hierarchy within ACM Private CA. Now, we also want to highlight what we call separation of duties. What this means is we want each individual role, IAM role, to have a specific job with least privileged IAM permissions. And so before we jump in, I just want to give it a few more minutes to make sure everyone is caught up. And so I'll give it another minute to make sure everyone is seeing this page, has logged in, and is doing okay. Okay. I'll assume if there's no questions, if people are just logging in, we'll continue. Please, if you're running behind, just pop it in the chat and we can wait. So like I mentioned, we're going to have a specific IAM role for each job that we're doing. Now, when we're setting up a CA hierarchy, that's a specific role. And one specific IAM role or a combination should be, should have the IAM permissions to, create the CA and, create the CA hierarchy itself. Now, for our workshop, we call that the CA admin role, and we'll look at what exactly that does. But at a high level, that is the role who administers and is responsible for creating and modifying the actual certificate authorities and the CA hierarchy. And so the first thing you're going to do is you're going to want to switch over to the CA admin role, and you will assume the role of the CA administrator so that you can create the CA hierarchy. What I'd recommend is just copying this role name. It's called CA admin role. You'll just want to copy it because it is case sensitive. And this will walk you through how to assume that role. So if you want to read the instructions, you could click on the tutorial right here, and it'll actually walk you through with PDFs on exactly what to do. But I'll walk you through it now live as well. So let's go over to your AWS account, and let's go to the top right-hand side where you see team role / master key at your account number. What you're going to do is you're going to copy your account ID. It's the first line right here on the top. It says account ID. You can hit this little copy button, and then you'll go to the very bottom left where it says switch role. Very bottom, switch role, and you'll click on that. So this is where we're actually switching over to the CA admin role. Now, typically within production, you'll have a federation service that actually federates users to these roles with a single source of authentication. But for educational purposes, we're just switching roles. The main takeaway here is that we have a role for creating the CA hierarchy, and then we'll have subsequent roles for each module. So you'll copy in, or you'll paste in the account number. And this is your specific account number. And then you'll type in the role name. So if we go back to the workshop, if we remember, the role name is CA admin role with camel case. So the C's capital, the A's capital, and the R's capital. Or you could just copy it, switch back over, and type it in here. You could give it an optional display name so that you remember what it is. I'll call it a CA admin role workshop, and I'll make it blue, and I'll hit switch role. Okay, so now we've assumed the CA admin role with specific IAM permissions to set up CA hierarchies, to create a new certificate authority, and such. And you can verify that that's the case on the top right-hand side here, where it says CA admin role workshop. If you see this, or like whatever you called it, you're in good shape. And that means you're now the CA admin. Now, if you don't assume this role and try to create a certificate authority, it will fail because you don't have the required IAM permissions to do that. This role is least privileged to give this user just enough access to create CA hierarchies and sort of administer them as well. Okay. Any questions on that? Just put them in the chat. So once we've switched roles, we're going to go to manual CA hierarchy setup. So we're going to walk through this manually so that you can see really how easy it is, even with the console, to create a CA hierarchy. So so click manual. Now this workshop is self-service, so we have a lot of instructions here. Feel free to use them, but I'll walk you through them together here. So first and foremost, we will begin by creating a new CA hierarchy. We'll start with the root CA. This will act as your root as trust, and we'll also create one subordinate CA. This subordinate CA will actually do the issuing of the entity certificates for your TLS applications. And so let's start with step one, which is navigate to ACM Private CA. So let's go back to your console. Let's go to services on the top search bar and type in ACM Private. Just type in ACM actually, and it should be the first one here, Certificate Manager. And click on that. Great, so this is the Certificate Manager service, and within this, you can do both public and private certificates. We're going to focus on private certificates here. If you look on the right-hand side, you'll see something that says create a private CA. Okay? Create a private CA. And you'll click on that. And this will walk you through a process of actually creating the private CA. It should bring you to the ACM Private CA page, where again, you'll hit create a private CA in this orange box on the top right-hand corner. Now, if we go back to the instructions, that walked you through it. And you have two options here. You have either a root CA or a subordinate. And you see that within your console as well. We will select root CA because we want to begin by creating a new root of trust. And we'll hit next. Now, these are all optional depending on your use case. But we'll just call this example workshop LLC. We'll say this is the engineering department's root CA. we'll keep it as United States. Go down. US. And we'll type in Seattle, Washington. Now you could make this whatever you want. Now the common name, we're going to call it whatever it says within this workshop here. So let's call it Workshop Root CA. So this will be the common name. Now keep in mind, these are all optional. You can name them whatever you want. It will make a difference in the workshop, but feel free to copy what I wrote here as well. Okay, we'll hit next. Now here is where you can select your key algorithm. There are a few options. We're not going to go into detail here on this virtual workshop, but we're going to leave the default RSA to 2048, and we're going to hit next. Okay, so we need an ability to revoke certificates once we provision them. There are two options to do that. There's either the CRL distribution, the certificate revocation list option, or there's the OCSP option. Now, for this workshop, we're going to use the CRL distribution. And this will send your CRLs to an Amazon S3 bucket. Okay, so if you hit that checkbox and you look at the S3 bucket name, we should have a pre-created bucket for you to use as your CRL. Now, there might be two options here. It's really important that you select the ACM Private CA CRL bucket with your account number right there. So I'll just pause there. I'm going to go back to the instructions and walk you through the same exact thing we just walked through together, which is configuring your certificate revocation option with the CRL distribution and selecting the pre-created S3 bucket. Okay. So now we'll hit next. Now you can tag your resources. So this is similar to tagging any other AWS resource. This is optional, but let's give it a tag. Let's say Department Engineering. Now you can use these tags later on to do IAM authorization and for costing as well. And so we'll say Department Engineering. This is optional. You can skip this if you want. Now I'm just going to pause here and see if there are any questions. Okay, hit next. So now we want to configure the CA permission. So this checkbox will authorize ACM to renew private subscriber certificates. So this essentially gives the CA the permission to to perform automated renewals of the CA certificate. Now for the root CA, we don't want this. We want the root CA to be have a renewal process that's manual and that's done with human intervention. And so we're going to uncheck this and hit next. Now you can look through all of the configurations that you've set. As you can see, there's a root CA. We have the subject distinguished name options, including the common name, the key algorithm, the CRL distribution via the S3 bucket, a tag, not authorizing automated renewal of CA certificate, and we'll click to confirm. Now, if you're doing this live with us and you're using a temporary account that we provided you, this will not be charged. But if you're doing this on your own, make sure to actually delete any resource that you create through this workshop via CloudFormation. But for all those that are with us live today, that's all handled for you. So hit confirm. This will take a few seconds. Okay, so the CA has been created, but we actually want to also install the CA certificate on the root CA. This is called self-signing. We'll hit install the CA certificate box here on the bottom right. And it'll bring up a few options we have for the root CA certificate. We have the validity period. It's set to 10 years. You can make this higher or lower depending on your use case. Typically with the root CA, it's on the order of 10 or more years. And it's always a higher validity period than the subordinate and the issuing CAs. We'll keep the signature algorithm as SHA-256 with RSA, and we'll hit next. And then we'll hit confirm. So since this is the root CA, it will self-sign the certificate, and it'll store automatically for you all the private key material on the FIPS 140-2 level 3 Cloud HSM or Manage HSM for you. And as you can see, now we have the root CA that's active and created. So as easy as that, you've created now a root CA in about 10 minutes. Now, for those that may have fallen behind, I just want to highlight where we are within the console. So right now we're in the ACM Private CA service. If you've gotten lost or you're somewhere else, to get there, you'll go to the top left-hand corner on the search bar, type in ACM, and click Certificate Manager. And that'll bring you to the Certificate Manager service, and you'll go to Create Private CA. It's really important that you go to the Private CA feature within here. And then this will pop up your root CA, okay? Any questions so far? I'll just scroll down here. We did all this, and we'll hit some quizzes as well. So any questions so far, just write them in the chat. If not, I'll take that as a good sign. I'll give it a minute for anyone to ask any questions on that, and to catch up if needed. Okay. All right, so we're going to do a few quizzes. Now, keep in mind, as you go throughout this workshop, and if you want to revisit this later today, there are embedded quizzes throughout the workshop that will help you reinforce this learning. There's no grade. This is just for educational purposes, and we recommend you take them if you wish. So give me 1 second here. Okay. So let's go through this one together, and we'll leave a few of them for you to do on your own. So the question is, the ACM root CA that you just created has a tag with team and CA admin. Let's assume that we had it as team CA admin instead of department engineering. The same concept applies. Can you use tag-based authorization to set up access control to do this certificate authority such that only an IAM principal tagged with the same tag can access this private CA? Okay, so the question's asking, is there an ability to have a tag-based authorization model where the IAM principal that's accessing the CA has to match the same tags as the CA has? And so this is the IAM principle that lays that out. If we see, we have the effect allow, the action ACM Private CA all. You'd likely want to scope this down a little bit for production use cases. And then the resource is the actual ARN of the CA of the certificate authority, with the condition that the resource tag has to equal the principal tag, meaning the IAM user tag has to be the same, the key value pair has to be the same as the resource, which in this case is the certificate authority. Is that possible? Well, the answer is yes. It does support this. So just keep this in mind as you build this out. The tag-based authorization is a really powerful tool to have in your toolbox as you're thinking about how to create IAM roles and create least privileged access to your certificate authority. Okay. Any questions on that? Okay. All right, so let's move on to creating one more certificate authority. So now we've created the root CA. I want to create the subordinate CA below that. This will do the actual, will actually issue the certificates, and we'll need this for the module of the workshop that we'll be completing together. There's a lot more information here that I recommend that you go through by yourself for some background, and we'll do a quiz as well to reinforce this together. But we are skipping some quizzes in the fullness of time. But this workshop is extremely robust and has a lot of modules and a lot of information that I recommend that you walk through like after this as well. Okay, so let's scroll on down here to create subordinate CA. And we'll walk through these instructions together. So feel free to read through them if you want, or just follow along. So let's go back to our AWS account. So if we go to that tab that has the AWS account on the top, and if you're not on this page already, if you remember, you just type in ACM on the search bar, hit Certificate Manager, go to the Private CA option, and then you'll see the root CA. But now let's create a subordinate CA below that. So on the right-hand side, we have a button called Create CA. So you can see right here. We'll click that. And it's the same process, right? But instead of a root CA, we're creating a subordinate CA now. So let's check the radius button for subordinate CA and click Next. Okay, so let's make sure that everything matches up. We said it was engineering, United States, and you can fill this out just like you filled up the root CA with the same with almost the same information. So the same country, the same state, the same organizational unit, if that applies, and we called it Example Workshop LLC as the organization. Okay, you can make these whatever you want. And for this, and for this purpose. Now we're going to change the common name to Workshop Subordinate CA. And we'll leave it like that. Okay. Click Next. We'll leave it the same. The key algorithm will be RSA 2048. Click Next. Once again, now if we go to the instructions, this is exactly the same, right? So we'll use the same CRL bucket. We'll check the CRL distribution to revoke certificates via CRL. And we'll click that same S3 bucket. Now remember, there's two options here. Make sure we select the ACM Private CA CRL bucket. Oh, okay, great. Okay. Now keep in mind you can tag. So let's tag it again. This is optional. You don't have to do this. This won't affect the workshop in any way. But let's tag it in the engineering department. Click Next. So again, now we have this option again, right? If you remember, we just spoke about this. This is the this is giving the CA the authorization to automatically renew the CA. CA, we actually want this enabled just for ease of use, but you can decide based on your specific like use case. Okay. Let's click next. So once again, we have all of our information. Now, one thing I did want to dive into a little bit more on the second go around is the key algorithm options. There's a lot more information we could talk about here, but at a high level, if we look at the difference between RSA and something like the elliptical curve or the ECDSA, generally RSA is used for servers, but for embedded devices where sort of performance and memory constraints become a large issue, the elliptical curve options, the ECDSA, are more efficient, right? So you tend to see elliptical curve being used for sort of IoT type workloads and embedded device type workloads. So just wanted to highlight that. Okay, we see all of our configurations. We'll click select on pricing. Now, once again, if you're using this within this virtual workshop, these temporary AWS accounts, you don't have to worry about this. If you're using this on your own, please be sure to delete these resources before the 30-day trial's over. After that, these will cost, if you run it the whole month, they'll be around $400 a month for the certificate authorities. And then we'll hit confirm and create. All right, great. So once again, now we've created the CA, the subordinate CA, but we have to sign that CA certificate, right? So let's install the CA certificate. You have two options. You can either do external private certificate authority or an ACM private certificate authority. We're going to do ACM because we just created the root CA, but this is an important distinction that if you do have a root CA that's on-prem, you can absolutely use ACM private CA. There's a lot of architectures where we see customers actually creating subordinate CAs in AWS using ACM private CA that have a root CA on-prem. So it's a valid use case, but for this, for this workshop, we're going to use the root CA that we just created. So we'll click that first one, and we'll click next. So now we have a drop-down list that asks us which CA do you want signing this CA certificate, and we'll select the ARN of the root CA, and it'll populate, and it'll tell us, okay, this is a root CA. This has the common name workshop root CA, and it tells us the validity period, which is 10 years from today. Okay, let's scroll down. So like I said, typically the subordinate CA validity period will be around this time frame, but it's completely up to you depending on your use case. But it will be less than the root CA, so we'll leave it at 3 years. We'll leave SHA 256 with RSA. And let's check what we want to have as the path length. We'll leave it at 0. So I want to touch on path length briefly, and then we'll have a quiz question on it, I think, too. But it's an important concept that we really want to understand. So let's read this together. At a high level, path length tells you how many CA tiers is this certificate authority authorized to create below it. Okay? So put another way, if we leave this at 0, this will be the last CA tier within the hierarchy. Now, one sort of distinction to make here, which we call out within the workshop, a path length of 1 does not mean that only one CA can be signed using this CA certificate. You can sign 5 or more certificates below this, or certificate authorities below this, with a path length of 1. We're really talking about the tiers. So you can only create one more tier below this CA if you have a path length of 1, not one CA. Okay, so that's important. We're talking about tiers of CAs. Okay, so you can create as many as you want if you have a path length of 1 tier below that. But but you can't create another tier below that tier if the path length is 1, okay? Now, for our cases, we're going to leave this at 0 because we don't want any more CA tiers to be below this subordinate CA, which we're using as an issuing CA, okay? And so this means, with a path length of 0, this means that one subordinate CA can be under the root CA. Okay, let's hit next. Then we'll confirm and install the certificate. Okay, great. So we've done the first module, which is creating a CA hierarchy, right? We've created the root CA and we've created the subordinate CA. We've done it in less than maybe 25 minutes. It is now fully managed. We can enable logging, auditing, monitoring. We don't have to handle our private keys. It's managed for us. And now we can go about an actual use case together. Okay. One thing I wanted to touch on as well, which isn't, which we're not going to have time to touch on within this workshop in detail, but just want to make you aware of. AWS Certificate Manager, Private Certificate Authority, and works with AWS RAM, Resource Access Manager. So RAM enables you to share resources between accounts, between OUs, or between IAM principals. And so there are use cases where you might want to share a subordinate CA or an issuing CA with another account. Maybe it's a partner, maybe it's another account within your organization. And instead of creating a whole nother certificate authority at $400 per month, you can simply share that existing certificate authority to another account so that it shows up within that account, can be used, can be called via API, and can issue certificates within that second account, but in a sharing mechanism. So you're not creating a whole new certificate authority. That's done through RAM. We have blogs on this if this is interesting to you. And it's an important topic from both a cost optimization perspective as well as from a sharing perspective. Now you can do things like limit what types of certificate templates that partner can actually issue. You can audit and log exactly what they're issuing, and you can revoke access at any time. So I just wanted to highlight that. That's sort of out of the scope, but relevant to creating CA hierarchies. And it's a great way to cost optimize your architecture. Okay. So I don't see any questions coming in. So I'll just hop into the quizzes here. Okay, so the question is, for signing the subordinate CA signing certificate request, or CSR, there are two options. You can either use an ACM Private CA that's created with ACM Private CA, or you can use an intermediate or root private CA that already exists within your organization. So we kind of talked about this, right? You can either use ACM root CA, or you can use an on-prem root or subordinate CA. Let's say you already have an existing private CA within your organization and decide to sign the subordinate CA certificate with it. Which of the below statements are true? Okay. Option 1, root CA certificates may be already preloaded to the device and browser trustors that are used by your organization. Okay, so this is saying, hey, I have a situation where I've already preloaded the root CA certs within my organization. And so I'd want to do this and have the subordinate within AWS, but leave that root on-prem. Okay, so that sounds right. The private key for the root CA certificate may be stored on premises hardware security modules within your organization, okay? So this is saying you have private key material on sort of on-prem, like on-prem, like HSMs that your root CA uses, and you don't want to transfer those, right? So this is valid, and you can absolutely still use ACM Private CA to have a subordinate under that root that's on-prem, okay? The private key for your organization root CA certificate may be stored on AWS Cloud HSM. So you still have that private key material, but you're storing it on an AWS service called Cloud HSM, which is a cloud-based, like HSM. So yeah, that's another reason you may want to keep your root on-prem, but have your subordinate within ACM Private CA. You as a customer are responsible for managing the security, availability, and durability of the private keys of your organization's root CA. So yeah, if you have a root CA on-prem, you're responsible for all of these. Whereas if you have a certificate authority within ACM Private CA, it's a managed service, and AWS handles availability, durability, and the shared security model comes in here as well, though. But that's true. Okay, so it looks like all the above for this question here. Let's see. Great. So we're correct. Now here is the architecture diagram of a situation where you have an existing CA infrastructure within your organization. And so that's that gray box on the top. You have an on-prem root CA, an on-prem intermediate CA, but you're developing now AWS applications, private applications, and you want to do the issuing within AWS. So you'd create an issuing CA just like we walked through together about a minute ago in 10 or so minutes, but you'd sign that with the intermediate CA. So you'd have a certificate signing request, it would go to the intermediate CA, and that would sign the CA certificate. And then you could provision N entity certificates with this AWS CA, but still having your root and your intermediate CA on-prem. Okay, so that's really important, that it is absolutely possible. So how are we doing on time? So I'm going to skip these quizzes. The rest of these, I highly encourage you to walk through these. They're great learning. They walk through sort of, they'll give you answers as well. But for time purposes, I want to get on to the second module together. Before I do, I'm just going to pause and see if there are any questions. If there are no questions, let's go on to the second module. We'll click on the internal app exercise. Okay, there's a lot of text here. Now, when you go through this workshop by yourself, feel free to read it. There's a lot of good information, but I'm just going to walk you through it verbally. So this use case is an internal HTTPS application. Okay, so you can think of this as maybe an internal application that helps employees, maybe look at a wiki page. So this is a wiki page application, let's say, just as an example. It's completely internal, and we want to have a TLS secured end-to-end encryption between the clients and the server. That's the use case. Now, we're developing this application, right? So we don't want to be using the CA admin persona because we're no longer creating a CA hierarchy. We've created it, and now we're taking the role, we're putting on the hat of a developer, okay? An application developer that's actually developing this internal application. And so we're going to switch roles again, okay? So this is the app dev role. Now the app dev role doesn't have permissions to alter the CA hierarchy. It only has permissions to build the application. So it could provision ALBs, maybe EC2 instances, and things like that. But it cannot, create or delete, certificate authorities. It can only do the issuing certificate API call when it needs a certificate. And we'll walk through this together, but that's high level what we're going through. So let's go over to the console again. Great. So if we remember, to switch roles, we go to the very top right-hand corner here on CA Admin Role Workshop. We'll click, and let's copy the account ID. So the account ID is the second one here. You click the little copy icon, go to the bottom left hand where it says switch role, and we'll switch over to the app dev role. Okay, so let's paste in your account ID. Once again, this will be different for each individual walking through this workshop. And the role ID, or the role name rather, if we go back to the instructions, we could just copy it, or you can type it in. It's app dev role camel case. So app, capital A, capital D, capital R. We can just copy it and paste it in here. And we'll call this app dev role workshop, and we'll make it yellow just so we can see the difference between the two. And we'll click switch role. Cool. So now we are the application developer. If you look on the top right-hand side, you see this yellow badge that says app dev role workshop. Okay. So let's go to the home page of AWS, and we're still the app dev role. Now, once again, we've taken the persona of an application developer. Typically, this would be done through federation. The employee would federate in, would work on their application, but would have a set of IAM permissions that doesn't allow them to create a CA, but allows them to issue the certificate from the CA, for their building of application. So we're going to walk through this together. So what we're going to do now is we've pre-created an application. It has a load balancer and a backend server. And we want to put a certificate on that load balancer so we can have end-to-end encryption from the client to the server. So this is very easy if you're using an application load balancer within AWS. But keep in mind, you can use these certificates anywhere. But we're going to be using an ALB, an application load balancer, for today's purposes. So let's go to EC2. EC2. And click on EC2. So EC2 has a lot of options here, but we're actually going to scroll down on this left-hand panel, scroll all the way down until you see load balancing, and click on load balancers. Okay. Cool. So we're in the load balancers page of EC2. And you can see we pre-created this for you via the workshop. So you have an ALB. This ALB has a target. That target is a Lambda function, which serves the HTML for this wiki page, we'll call it. Okay. Great. So I just want to, great. So what we're going to do is we are going to copy the DNS name. See the DNS name here? We're just going to copy it and put that somewhere safe. Okay, so each DNS name is going to be a little different for each account. So copy that, put that somewhere safe, and we'll go back to ACM Certificate Manager Service. So since we're the application developer, we don't want to create a private CA. We just want to request a certificate. So we'll click request a certificate. Now we can request a public certificate or a private certificate. So as we've talked about, this is a private application within the intranet of a business. And so we're actually going to select private certificate. Click next. Okay. So here we have a drop-down list, and we're only going to do the issuing on the subordinate CA. So we're going to select this first option here to issue the certificate from the subordinate CA. So click on that. It'll self-populate. It'll tell you exactly all of the parameters that we put in. And it's asking for a fully qualified domain name. So this will be an internal DNS name that we just copied, right? So let's go over to wherever you put that DNS name from the application load balancer and paste it in here. So let's just make sure that we're following along. We've selected the subordinate. We've selected the fully qualified domain name from the ALB that we got. That's it. You can tag it if you want. You can tag the certificate, for costing perspective or for identity management perspective, in terms of authorization of what you can do with it. But we're not going to do that. Click understand, remove the tag, and we will click request. Great. So we see the certificate here. You can see all the metadata about the certificate. It said pending validation. Now it says issued. So it's good to go. It's ready to use. Okay. So there's a quiz here. I'm going to skip it because I want to make sure we hit on the rest of this module. But I, once again, just encourage you to check it out. So now that we've created the certificate, we have to attach that to the ALB. The first thing we're going to do is we're going to create a target group for the load balancer, meaning what should be the backend target of that load balancer. So once again, we're going to go to EC2, click EC2, and we're going to scroll all the way down on this panel right here, zoom in, and there's a target groups option that's under load balancer. So if you can't find this, just keep in mind we're actually on the EC2 page, and we're on the left-hand side panel. Okay, and you hit target groups. So there's none created yet, so we're going to hit create target group. Okay. Now, this will walk you through it in more detail, but what we're going to do is we're going to create a Lambda function as a target group. This means that behind the application load balancer, there's actually a Lambda function that's being targeted when requests come in to serve the web page or the application. Okay, Lambda dash target dash group. Once again, Lambda dash target dash group, and you select Lambda function. Okay, we'll click next, and then we will select the actual function that we want to target. So okay, so there's a few here, and these are listing the actual Lambda functions that are within this account. This is very important. You want to select the builders dash Lambda dash origin dash 1 and click latest. Okay, so the builders, it starts with builders. Now this is the Lambda function that actually serves the web page. Great. So as you can see, we've created it. Now we're going to go back to the load balancer on the left-hand side here. And we're going to go to listeners, and we're going to go to add listener. We're going to go to HTTPS because, once again, we want secure communication. We're going to leave everything default except for the certificate. So we want to actually use the SSL TLS certificate from ACM. And here it is right here that we've provisioned, right? So we're attaching that certificate, and we're going to hit forward. And so we're forwarding to that target group that we just created, which is essentially that Lambda function. And here's a certificate that we just created, and we're going to hit add. View listeners. So it's as easy as that. And now you've created a secure application load balancer that can now get requests securely. So let's try it out. So let's go to this address here. And it may take a second because we've just actually created the listener. So we'll give it a few moments. We'll give it a few moments there. Okay. Okay, so it's giving us a security warning because we don't have the root certificate loaded on the web browser yet. But if we ignore them, we can see that the target group worked. But we're not there yet because we want this to be an actual secure connection, and it's not. That is because if you remember, with private certificate authorities and private certificates, the administrator has to actually load the root cert, its PEM file, to the internal browsers. Okay. If this was a public cert, you wouldn't have to do that. But since this is a private application, you actually have to do that. So for each browser, it's a little different. We list instructions for each browser here. I'm going to use Firefox, and it'll walk us through how to load the root certificate body to the application, to Firefox. Okay. So let's just do that together real quick. Okay. So let's go over to ACM and let's grab that root certificate. And we actually want to scroll to, we want to go to create private CA. And you should see your private certificate authorities. Now you're going to want to select the root CA and then go to, if you see status, you should see CA certificate. We're going to actually want to load the root CA certificate body into the Firefox certificate store. So let's hit export. It's called certificate.pem, and we'll save file. Okay. So I am going to now load it. Now, like I said, each browser is a little different. And I'm going to do this relatively quickly because there's not a ton of learning that comes from this, but essentially you're loading the certificate to the Firefox browser. You'll hit import, and we'll go to recent, and we'll select that PEM file when it pops up. So here it is, certificate.pem, and we'll hit open. Let me see if you're seeing this. Yes, you are. We'll trust websites, users, hit OK, and then hit OK. So the live feed may have cut out there, but you're essentially just following the instructions within the workshop to load it into the Firefox store so that it can trust this website. If we refresh it, you can now see that there's a lock symbol, and it's telling us it's secured by exampleworkshop.llc. So hold on, let me just share my screen a different way. All right, great. So now we're sharing my screen again. So we refreshed now that we loaded the root certificate to the Firefox store. And if you see on the top left, you see there's a little lock button. If we open that, it's telling us that it actually is secure now. It's trusted. If we go in a little bit more, it's telling us that it's trusted by this example workshop LLC. And that is the root CA, and that is the hierarchy that we've just created for this internal web app. Okay. So as you can see, this is a very simple website. It's a hello world, but you can imagine any internal applications, whether they're container-based, like IoT-based or server client-based, you can use the power of the ACM Private CA service. Okay. So within this workshop, so far, we learned how to create a CA hierarchy, both a root CA as well as a subordinate CA. We've learned about separation of duties in terms of making sure that we have a role for application developers and a role for CA administrators. Okay, and then we've also walked through actually building the CA hierarchy, but then also using it in a TLS and entity certificate workload where we have an application load balancer that's backed by some sort of Lambda function or some sort of server that needs secure TLS end-to-end encryption. And we've shown that you can do that in a matter of minutes. And keep in mind that we've done all this with the console, but this can all be done programmatically via the API. But otherwise, thank you all for joining. I hope you had a lot of fun, and I hope you learned something new. Have a great day.